guys, we're doing 29 for notes. This is day 2. We're actually just doing one example, just kind of for more practice. Tomorrow we'll do only one more also. So here's our function, and we're asked to graph it. Again, you should be doing this without a calculator. I will do every step without a calculator. You can have it, but I still need to see all of this work. Basically, I need to find these 5 things, plot them, and then if I need a couple more points, I can plot a couple more points. What we need to do first is get this into one fraction. So they have different denominators. Let's get a common denominator by multiplying this one by this piece, x plus 1. Multiply this piece, or this fraction, by x plus 3. Then you're going to simplify. So distribute that out on the top. Distribute this out on the top over here. Notice now they have a common denominator. And so when they have a common denominator, you can write that as a single fraction. Don't forget, when there's a minus here, you have to subtract this whole fraction. That's what this says, subtract this fraction. So I have to subtract both parts. So it's going to be minus 2x minus 2. Let's clean up the numerator a little bit, combine our like terms. You could probably do this entirely without my help, do the whole problem without me, and then check it since we did it yesterday. We're good to go here. We have the numerator and denominator simplified, nothing cancels. If this negative were not here, the top factor and the bottom factor would cancel. That would create a hole, which is basically just a tiny little opening in the graph. It doesn't really do much else. It's just not connected there. There's just a tiny hole. So there's going to be no holes, and we're going to look at the denominator to see what x values we cannot have. So we cannot have -3 or -1. There will be a vertical line or a vertical asymptote at -3 and -1. So x equals -3, x equals -1. Let's draw those now. And there are no holes. Horizontal asymptotes. We'll look at the degree. The degree of the numerator is 1. The degree of the denominator, if this were in standard form, would be 2x squared. So the denominator is larger. That's happening a lot. If the denominator has a larger degree, x squared is larger than x to the first, then you will get y equals 0. So we need to plot a horizontal asymptote at y equals 0. Alright, let's find the last 2 things, x-intercept and y-intercept. Pause the video. Here's my work for you to check once you've done that. And then I'm going to write them up above, my x-intercept and my y-intercept. They are points, but I won't be too picky about that as long as you label them. X-intercept, y-intercept. So let's plot those. I'll go ahead and do them in red. X-intercept, here's my x-axis, and I have 1. And then my y-intercept is 1/3. I mentioned this yesterday. You might think, well, how can I have a point on this asymptote? I thought it doesn't touch the asymptote. That's true for vertical. You will never have points on a vertical asymptote. You can have a point on a horizontal asymptote. This horizontal asymptote just means it's approaching 0 over here and approaching 0 way over here, but it actually can touch. So with this information, let's see what we can do. Sorry, I realized I plotted 3 and 1. I need to be at -3 and -1. Sorry about that. Well, that changes some things. Okay, look at these 3 sections that I have. Something's going to go up here or here because it's not going to cross through because it doesn't have any intercept. Something's either going to be up here or down here. And then over here, we kind of can see what's happening. It's already touching here, so that means it's going to come, I have to connect both of these 2, and it's just going to come right below. It's not going to, it cannot come down and then go back up because that would create another intercept. So it can only touch that one time. So the only way to connect this point with this point is for the graph to do this. We don't actually have to plug in a point because we know it's going to stay below there because it's never going to come back up. And it can't stay at 0 because it's not going to end at 0. It's going to end slightly above or below. So this middle section here, remember I said the rule is if this is going up forever, on the other side of this asymptote, it will be going down forever. So the question is it like a parabola, a U, or does it kind of curve back up? Well, if it curved back up, wouldn't there be a point here that it's going to have to touch? There are no points. I cannot cross this, otherwise I'd have more x-intercepts. So it cannot cross this line because there's no other x-intercept. So it's just going to kind of go up and back down. That's terrible. And I'm not grading how high up you go. It might go all the way up, might not. You don't have to be specific as long as you don't make another x-intercept because there's not one. Okay, over here, is it going to be up here or down here or both? Well, it's not going to cross over because that would create another x-intercept. So it cannot do this and cross here. That's another x-intercept. We were only told we had one and we already plotted that. So what do we know? We have a vertical asymptote. It's being approached from the bottom, the negative infinity over here. So on the other side, it's going to go up forever. So that tells us it's going to end up here. Remember, it's going to go out here forever, so it's going to do this. Okay, so that is my graph. You don't have to plug in any other points as long as you show all this work. All right, that's it. Go ahead and practice and show your work while you're doing it, just like this video. You can check in your calculator. It's always good when you're all the way done, type in the original into y equals, hit graph, and see how you did. That's a great way to check it.